rules for filling electrons in the orbitals. Basically, we follow different rules before we fill electrons in the orbitals. So the first rule which we need to discuss is its Aufbau Principle. What is the principle? Actually, Aufbau Principle says about the manner in which the electrons are going to be filled in your atomic orbitals in its ground state. So if we say that electrons are filled into atomic orbitals in increasing order of your orbital's energy level, and the Aufbau principle is basically being used in order to understand the locations of electrons in atom and their corresponding energy levels. This principle helps us to understand the location of your electrons in a particular atom and the energy levels to which it is being associated. So when we say the Aufbau principle, that is the order in which the energies of your orbital will increase and the order in which the orbitals are being filled is your 1s, 2s, 2p, 3s. So this is the basic structure or the basic order which we follow in order to fill the electrons in different orbitals. So here we take it as your n, that is equal to your n, which is nothing but your principal quantum number. Hence we go as in your increasing order, that is your n1, n2, n is equal to 3, 4, 5, and this is the representation of your azimuthal quantum number, where the first line, first column says about the azimuthal quantum number where it is equal to 0, and that takes up the s orbital, or and the next one is your if your azimuthal quantum number is equal to 1, that takes up the p orbital, and if the azimuthal quantum number is equal to 2, that takes up the shell or the orbital, that is your d, and next is your f. So the electrons are being filled in the energies or in increasing energies of the orbital will increase, and that is the order. So the sequence goes in this way: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 4s, 5s, and so on. So this is the basic method where the electrons are being associated or the electrons are being filled in different orbitals. And the next method or the next rule which we should have in our mind is Pauli's exclusion principle. What we should understand from the Pauli exclusion principle, it says that if we try to fill electrons in the different quantum numbers, or we can say in an atom or molecule, no two electrons can have the same 4 electronic quantum numbers. We know the 4 quantum numbers, that is your principal quantum number, azimuthal quantum number, magnetic quantum number, and the spin quantum numbers. So according to Pauli's exclusion principle, no two electrons can have the same 4 electronic quantum numbers. So the Pauli's exclusion principle will tell you about the no two identical fermions. You can say that it can simultaneously occupy the same quantum state. Hence we need to follow 2 rules for your Pauli's exclusion principle. That is, only 2 electrons can occupy the same orbital, and the 2 electrons that is being present in same orbital will have opposite spins, or it should be anti-parallel. Because we could say that even if there are chances of having first 3 quantum numbers to be same, it is obvious that the spin quantum numbers could not be same, because it will always be either clockwise or anti-clockwise. And the third rule which we should have in mind when we are filling the electrons is Hund's rule, that is Hund's rule of maximum multiplicity. According to this rule, for any given electron configuration, the lowest energy term is the one with your greatest value of spin multiplicity. So we could say that according to this rule, electron pairing which is going to happen in your p, d and f orbital cannot occur unless and until each orbital of your given subshell is going to contain at least one electron, that is in each, or it is singly occupied. When we are trying to allot the electrons first to each shell, or we can say each subshell, first we have to allot single electron, one electron to each subshell, and then the sequence of your pairing should start. This is the concept, or this is the rule given by Hund's rule, and it is called as Hund's rule of maximum multiplicity. Hence, when we try to fill electrons for different orbitals, we are supposed to follow certain rules, and those rules are given by three principles, that is your Aufbau Principle, Pauli's Exclusion Principle and your Hund's rule. Thank you.